Welcome to Veteach. Now we are entered into the last concept of D-Alemberts principle. So that is D-Alemberts principle applied to plane motion. We know what is plane motion is. Plane motion is nothing but the combination of linear motion and rotary motion. Is there any such thing in reality that performs both the operations at a time, linear and rotary? Yes, definitely. The wheels of a lorry, the wheels of any automobile, which will rotate and parallelly they goes linearly also. So the best example for plane motion is wheels, moving wheels, automobile wheels. Clear? So here what happens is, for example, take an example of figure. In this figure is a this a wheel, and if you apply a force horizontally on this head, then what will happen, it will start rotating. So it will start rotating and parallelly it will go linearly also. So linearly going is nothing but mass into acceleration, and rotary is nothing but I into alpha, where I stands for moment of inertia and alpha stands for angular acceleration, where m stands for mass of the body and a stands for linear acceleration. So when a force is applied on a wheel or pulley on a cylinder as shown in the figure, then the body starts to roll on the surface. The body starts rolls on the surface. The body will simply rolls on the surface. The rolling is nothing but the combination of linear and rotary. So this rolling body will have both the translatory motion, rectilinear motion, linear motion. All they have same meaning, that is linear motion, and rotary motions as shown in the figure B. Hence, we can write the equations of rolling body in the plane motion. Algebraic sum of the F minus ma for linear, algebraic sum of the moments minus I alpha for rotary is equal to 0. Note, the rolling of the body must be without slipping on the surface. Then only we can use the above equations. Slipping, what do you mean by slipping, sir? Slipping means, for example, a body is moving on a surface, rolling on a surface. So until it completes its journey, it must not lose a contact with the surface. It definitely has to be in contact with the surface only. For example, it is moving like this, at a particular point it loses its surface contact, and then after 1 second or 2 seconds it again comes into contact. It is not comes under the concept of plane motion. It must be in contact with the plane which on which it is moving. There is no slipping means it is losing the contact with the surface. It should not happen. It should not happen. Then only we can apply the plane motion. So plane motion is nothing but the combination of linear motion and rotary motion. In this concept, there is a single body which will perform both the operations. First of all, we have applied D-Alemberts principle for linear motion, where we have done lift problems, block problems, etc., etc., where we have drawn free body diagram, and we have applied the linear motion equations F minus ma equal to 0, where F stands for the algebraic sum of the forces and ma is the inertia force. And then we move to rotary motion, fixed axis rotation. In this rotary motion, what we have done is we have applied both the equations for rotary and linear. Why? For rotating a pulley or rotating a rotary motion body, then it must be a linear force must be applied on the body. So the block which is rotating the body must be considered as linear motion, F minus ma equal to 0, and the pulley which is rotating with fixed axis, that must be considered as m minus I alpha equal to 0. So both the conditions have done, but in the rotary motion, two different bodies performing two different operations. But in this plane motion, there is only single body performing rotary and linear. A solid cylinder of radius r and mass m is released from rest. Released from rest means the initial velocity w is u equal to 0. It is not for linear, and omega not equal to 0. That is for rotary. Clear? And rolls down on an inclined plane as shown in the figure. Now find out the acceleration of the center of the mass. Find the maximum inclination for which the rolling without slipping. We need to find out the unknown angle beta also for mu is equal to 0.2. He has given mu is equal to 0.2. It means we have to consider the friction. We have to consider the friction. So if you see motion, this is an inclined plane. This is an inclined plane. Clear? This is an inclined plane. And this is beta, inclined plane, and this is beta angle. Now this is the pulley. This is the body which is rolling over the plane, which is coming down. The direction of motion, linear direction of motion is like this, and rotary direction of motion is like this. So now what we have to do? We have to do the draw the free body diagram. This is the free body diagram. Weight vertically down, and weight vertically down means weight will be divided into two of its components, and the reaction perpendicularly at 90 degrees with the inclined axis, and this is the MA. This is the MA. Sir, why you have written MA in this direction, sir? Where is this MA actually? I have written MA means MA is nothing but the inertia. Na? Inertia means what? Inertia is the opposing force which will try to save the body from being rolled, which will try to save the body from being moved. That is so. That's why I have shown this in free body diagram, but it is not necessary to show this arrow. Simply you have to go for mg sin beta, mg cos beta, because weight is nothing but w is nothing but mg, and it is making beta with the vertical. So mg cos beta, w cos beta, mg sin beta, w sin beta, and the body is going towards in this direction now, so the friction will be in opposite direction. So for this concept, you need to go that first of all consider the horizontal motion. For horizontal motion, apply D-Alemberts principle. All the horizontal forces applied on the body is equal to mass into acceleration in x direction. X direction means x direction acceleration. X direction acceleration. What is the vertical direction acceleration? 0, because the body is not going vertically, na? So the vertical acceleration becomes 0. So now algebraic sum of the horizontal forces. You see mg sin beta and minus f is equal to ma, then f is equal to mg sin beta minus a, equation number 1. Okay, now consider vertical forces algebraic sum of the fy equal to may, that will become 0 because there is no vertical motion now. So algebraic sum of the vertical motion becomes 0, so mg cos beta minus r becomes 0, that is equation number 2. Now come to rotation. Linear is completed, the same roller now it is rotating also, so consider the second case, rotation. So algebraic sum of the moments minus I alpha equal to 0. So moments is nothing but force into perpendicular distance, which force? The force of friction, because we consider this as point of rotation, this as rotation point. So here there are three forces, but they become 0 because we know that the force applied to rotate the body is applying on the point of rotation. Then the moment created by the force becomes 0 because there is no perpendicular distance between the force applied to the point of rotation. But here friction develops at the contact surface, so there is must be a different distance from point of rotation to the frictional force. So f into radius r, so f into radius r minus I alpha is equal to 0. So substitute f here, here, and substitute all the remaining values in this, then finally you will get a is equal to 2g by 3 sin beta, that is equation number 4. Now given mu is equal to 0.2, now from equation 3 fr is equal to I alpha, I alpha is nothing but f is nothing but mu into r, and r is the radius, I is nothing but mr square by 2, and angular acceleration is nothing but linear acceleration by radius. So substitute all the values. After cancellation all these things, you will get a is equal to 2j by 3 sin beta, and if you continue doing this, finally you will get beta is equal to 34.6 degrees and acceleration is equal to 3.7 meter per second square. So first of all, don't try to copy the problem, here. You need to concentrate on the logic. So what is the question type, what is the type of the question? I'm telling you, this is one of the important questions. So sorry, I don't forgot to put this important, very important question. There is an inclined plane on which the body is rolling, so rolling and parallel it is translating also. So for this concept you need to consider the linear motion of the body, and parallelly you need to consider the rotary motion of the body. After doing all these things, you will finally get the answer. How I have told you, for doing answer you need to go through the free body diagram. If you don't know how to draw the free body diagram, but you know the procedure, I'm telling you, you will be wronged, you will definitely lose the marks. So I have made a video in your second unit that how to draw a free body diagram. Go through that free body diagram concept. Once you go through the concept of free body diagram, then all these free body diagrams very easy to draw. Once you draw the free body diagram, simply you go for algebraic sum of the horizontal forces, algebraic sum of the vertical forces, and algebraic sum of the moments, etc. Solving one and only, one by one. Finally you will get the answer. What is the question is given? Find out the unknown angle beta, the angle of inclination, that is 34.6 degree, and then a is equal to 3.7 meter per second square. So acceleration of the body with which the body is moving translatory is nothing but 3.7 meter per second square. I hope you are understanding my lessons, I hope you are getting my points. If you want anything clear, if you have anything more clear, then I am always available. Veteach is always available for you. So this is the concept of D-Alembert principle in the third. I hope you are understanding. I want you people to listen the videos continuously, and then practice the questions questions from the question papers and practice the question from the material provided by Veteach.